So I'm hoping when you look at this, you notice that how we've got the rectangle inside and all the different rectangles inside. And what we're going to do now is we're going to learn what goes on the outside. Well, mathematically, we're going to try to find the factors. Remember when we're multiplying, if I do 2 times 3, those are both factors of 6, right? I also have 1 times 6, which is also a factor of 6, and that's going to come into play later. But because they've already given me this rectangle here, where's a pointer here. So you see how right in here I've got a 4 by 3, so that's 12. What is represented in there? Well, I see 12 units. So what are the dimensions of this? Well, I see 4 along this side, 3 along this side. So the factors of this 12 is 3 times 4. And I know it's 3 times 4 because of the dimensions. So, I mean, that's not so much. How about this one? I've got an X, I've got an X, I've got a 1, 1, 1, 1, 1, and 1. So isn't that, what's inside? Isn't that 2X plus 6? 6, Dan, not 2. So isn't that going to be 2 this way? Oh, let me do the algebra tiles, sorry. Isn't that 2 this way? And an X plus 3 on top, so that's 2 times X plus 3. We just undistributed that 2, right? If I distribute that 2 through, don't I get this? So that I factored that expression to be the 2 times X plus 3. And this whole box idea is actually pretty useful for that. So what do you think about this? Let's see here. What kind of square is that? What rectangle is that? And what do those represent? If you want, you can stop the video and think about it. I'll just keep going. I see an X squared. I see an X, an X, an X, and a 1 and a 1. So I see an X squared plus 3X plus 2. So how does that factor? Well, I think I see an X. I see 2 units this way. I see an X this way. I see 1 unit this way. So I'm seeing X plus 2 times X plus 1. And now if you think about all the multiplying polynomials, what we do, remember how I'm going to multiply the X through? I mean, certainly I could do X times X gives me X squared. I don't know if it makes a lot of sense to talk about going backwards when I've already got it, but I do know that X times X is X squared. Here, let me get a pointer going. X times X is X squared. X times 1 is, let's see, so I've got X squared, then I've got X times 1 is 1X. And then if I distribute the 2 through, I get a 2X plus 2. And if I add those together, don't I get this expression here? Okay. So how about this one down here? I see an X squared. I see an X, an X, an X, an X, an X, a 1 and a 1 and a 1. So I see 2X squared plus 6X plus 4. So how does it factor? Aren't those the algebra tiles? And aren't those the tiles for this? So isn't that 2X plus 2 for the top times X plus 2 on the bottom for the right-hand side, left-hand side? And that factors that. Now, if we think about distributing to check, isn't that 2X squared plus 4X? And then 2X plus 4. And doesn't that give me 2X squared plus 6X plus 4? So that's what we're doing here. Okay, so then for this one, they're telling us the expression, and what they want us to do is they want us to arrange those tiles into a rectangle inside. Okay, so if I could get you a copy of a mat like this, I would. what do they have? An x squared plus, let's see, I think I have access to drawing squares here. That's a rectangle, not a square. Just a minute, I'm going to pause this video. This software I haven't used in a while. So I did what I did, played around with this for a little bit, and I knew the x had to go here, but then I had to decide what am I going to do with these 5 x's to make a rectangle. And see, I got to have a rectangle in here. I know I drew it a little weird there, but one hint that I knew that I had to get the 6. So I knew what are the factors of 6? Well, 3 and 2. So that'll let me arrange it this way. So now that I've got my rectangle in here, all I've got to do is come up with what are the factors. Well, I see an x. Oh, can I just write an x? You guys okay with me just writing x plus 2? I mean, using tiles, it would look like this, right? And this way, don't I have an x, and then there's a 3 up here. So that tells me that x plus 3 times x plus 2 is what I multiply to get x squared plus 5x plus 6. And we can check if we, here, let me write it like this down here. X plus 3 times x plus 2. We can certainly use the box method if you want, but I also know that x squared plus 2x, and then I'm going to do x times 3 and x times 2. So 3x plus 6, doesn't that add to give me x squared plus 5x plus 6? So give you a little glimmer of what I'm doing with this. I'm looking at those 6 units and deciding how can I arrange those 6, the factors of 6, in order to make a rectangle. Okay, so now they're asking me to factor this. Well, let's see. Let's try building the square. Well, building the rectangle inside. Here's my x squared, and then I gotta get 4 in the end with 4. So what if I do this? I should let you explore this, and if we were in the classroom, I certainly would. I would have you playing around with algebra tiles and figuring this out. But you see what I did is I knew 2 times 2 was 4, and that would give me the dimensions this way. So x plus 2 and 2. So it's going to be x plus 2 times x plus 2. Now, these are the same things, so we could write this x plus 2 squared. That would be an equivalent way to write that. Okay. Now to FOIL to check, or to multiply to check, x times x and x times 2 is going to be x squared plus 2x. And then if I distribute the 2 through, I'm going to get 2x plus 4. And lo and behold, if I add those together, I get what I started with. Okay, so that's factoring quadratics. This will come in useful when we're solving them and looking for where these things as equations cross the x-axis.